Hey everyone, in this episode we're going to be getting our septic system up and running. We did not install it, but if you don't know how they work, I'm going to show you everything about it. Captain Morgan. No, okay, let's be serious. So, like a long time ago, we had a video where we installed all the leach field, all these tanks, everything. It was our fourth video. You can go check it out. We'll put it in the description. It was one of those where we were like super shy and serious and everything, but I think there's good content in it as to how everything got installed. But I'm going to give you a quick little recap of some of that right now, because in this video we're going to be getting all the electrical. We might get some water going, we'll see, I'm not sure, but at least all the electrical will be working because we have a siphon dosing system. So anyway, what's taking place is you might see this little clean out over there. That's the sewage coming in from this side of the house. Over there we have another clean out. That's the sewage coming in from that side of the house, and then they mix here in a Y, and then they come into this tank. You might see actually two covers, but they are actually one single tank. So what ends up happening in here, the poop, the waste, everything, it comes in here. There's some bacteria, and then the bacteria starts to decompose the solids and everything. And then what happens is the oils, they go all the way to the top, so they call it scum. Then all the solids, they start to drop, and then the purpose of the bacteria is to liquefy that as much as possible. And then in the middle you end up with this liquid that basically ends up going onto this side of the tank, and then that liquid ends up going down to this tank that has actually a pump. We do have a pump because we did not have enough height to do it gravity based, so that's why it's all electrical. And then this pump, what it does is it basically sends all the waste down to the leach field. We have 4 lines. Some of them are for backup. Anyway, that's what's happening in a nutshell. So what I'm going to be doing now is we have an alarm up there, basically a controller that takes care of the pump and all that kind of stuff, and we're going to be hooking it up. We were in the process of wiring this septic system, and they said, okay, you need to wire 9 wires down to the tank. And we did, except when we were running the fish line, we thought this was the place that it opened on, and we tried to open it and it would not open. And I'm glad we decided not to force it too much, because otherwise we probably would have broken it, because that's not the place to open it actually. So then what I said is, okay, I'm gonna call all service septic. Eric came over and he showed me how this stuff worked, and it turns out that you open it right here, not right there. And the reason I didn't know you opened it right here is because it was buried beneath all this dirt. So now I know, and now you know if you ever run into this issue. While I'm here, I might as well show you how this stuff works. Now, why don't we start with the sensors? They're right here. So you see these floaters right here? So we have this low floater. So basically what this means is that everything is working normally. Turns on the pump that starts feeding the septic, the leach field. So when this guy is on, everything is looking good. But then we have this other floater, which is when this guy comes on, that means we're starting to overflow. So the alarm on the controller will come on. So that's what that means. Obviously, when this comes on, the pump should still be working because we want to feed the system. But to be honest, I'm not sure what will happen. I guess we'll find out later in this video. Okay, cool. So these are the sensors. Each one of these have 2 wires. 2 wires that we're going to be running in. We're going to be running number 14 wires for them. And then we have 3 other wires for the pump. So the pump is a 120 pump. Let me see if I can get it out. Well, I'd rather not get it out. I don't want to break anything. Anyway, what this pump is one of those well pumps. So it's a very nice pump. That's what they say. And that's what's going to be feeding the system. So the pump runs on a 120 volt system. So it requires neutral, ground, and load. It requires a 20 amp serve. So that's what's going on in here. Let's run the line again. Hopefully we can get all these cables connected in here, and we should hopefully be able to test it. And this is the reason why we couldn't get the fish line to go through. Our conduit is bent, so we're gonna try to heat it up and hopefully bend it into place. So a little bit of bad news, when we ran these cables down and we were testing them, it turns out that one of them is kind of broken or it's intermittent. The bad news is we're going to have to pull them out, find that cable and basically replace it. That said, let me mention real quick about cables. First off, somebody asked me, one of my guys said, why don't you just use one of the Romex and peel off the sheathing? You cannot do that. It's against code. You must use one of these THHN cables. It doesn't matter, they come in different sizes, but you cannot peel out a Romex because Romex cables, they're meant to be for interior, and THHN cables, they can be on the exterior as well. Of course, covered with their sheathing and whatnot, but there's something different about them that's not allowed. So that's the reason why it's important that you use the proper cable when doing this stuff. There's two kinds of cables. There's the solid core cable and then there's the threaded cable. The solid core cable is really nice and easy to work with. The problem with solid core cables is that if they break, it's really easy for them to break and become intermittent, and then you're done with that cable. So that's the reason why in many applications it is the threaded cable is used. So basically it comes with a bunch of little threads of copper that basically run the electricity through it. The reason for that is because since you have redundancy, in case one of those threads break, you don't necessarily break the entire circuit. That's the reason why they are used, generally speaking, for important applications. Finally, so when we run these cables again through the conduit, we're going to be applying some petroleum jelly to allow them to slip a little bit easier. We're going to be applying this petroleum jelly on each individual one so that we have a less hard time pulling them in. My guess is that the cable broke when we were pulling it in. So anyway, let's get that going and hopefully we'll be done. We're about to get some water into the tanks. So what's supposed to happen is that this tank will either fill simultaneously on both sides, or it'll fill on this side first and then on that side. I'm not actually sure, but we will find out here in a moment. Then once this tank overflows a little bit, it will overflow onto this other tank, and that's where we have the water pump for the leach field. The reason we're filling it with water and all that stuff is because you should never test pumps without water. So we want to fill it enough to be able to test it. So let's see how that goes.
What we're doing here is a very important test for our peace of mind. With this hose, we're going to be filling up the septic system. Now, why this test is important is because when we did our plumbing test a long time ago, it was only for the components under the slab, but we have a plug, so we have not tested the system end to end from the plumbing of the house going all the way into the septic. If you're familiar with our story, you have seen those plumbing videos. If you have not, we have two videos because it's an interesting system. We have two independent stacks that then come into a Y and connect to the same septic. For this test, we're going to run the first one here down in the mechanical room to cover this side of the house, and a second one on the basement so that we can cover the other part of the house.
Right. It's coming out.
Okay.
It's coming out. Looks good. We've been filling this tank for a bit of time today. The way it actually works is it does come up first on that side of the tank, but it has a low barrier, so this one follows relatively quick. This full tank is fully passive, so no electronics or anything. And the key thing is, I don't know if you can see that pipe over there. That's the one that once the tank overflows enough, that's the pipe that's actually flowing the water onto the bottom one. So let's go down there and I'll show you. Now I'm on the bottom tank where the pump is. You might see that the water is coming up right here. It's coming out relatively high. This is a much smaller tank. So now what we just need to do is wait for the first bladder to come up and we should be able to test the pump. It's taken a long time to fill these tanks, but we're finally there. We're going to shut off the water and we're ready to test the pump. Ooh. Oh shit. I put it on auto, nothing happened. I'm gonna put it on manual. Let's see if something happens. Okay, so big mistake. One of the first things I teach you in electrical engineering is to make sure that things are on. And I didn't turn on the breaker, so let's turn it on. So now let's turn it on. Let's put it on auto. Nothing should happen because the floaters are in such a position that nothing should happen. And correct, nothing happens. So now let's put it on manual, and manual should turn on the pump. It is. So let me show you real quick how this Orenco Systems pump controller actually works. Real quick, it has two breakers, pump and controller. The pump is at 20 amp, the controller is at 10 amp. We have independent circuits down there on our main panel breaker. So we have here is we have the two grays. The gray ones are actually neutrals for pump and controller. The white one and the black one are the 20 amp for the pump down there. This cable goes through the conduit. Then we have this auto, off, and manual. Auto is basically self-controlling by the controller. When I put it on manual, it actually turns on the pump regardless of what's happening. Next, there's these little counters. I have no idea what they're counting, so I hope you do know and let me know. And then there's this little ABB controller of sorts. It's kind of like a three-phase motor controller. To be honest, I'm not super familiar what it does, but what I've noticed is when the pump comes on, this thing, like switches, they go inside. With that, we do have the three sensors, orange, blue, and yellow. They're for the bottom, medium, and the top floaters. In a nutshell, this is how this is working. Turn on the middle one. That's perfect. The pump came on. Okay, perfecto. Ya estuvo. Perfect. So he turned on the middle one. That typically turns on the pump so that we can drain onto the leach field. Then the second one, or the topmost, is the alarm, and you heard it. Everything seems to be working correctly. Awesome. With this, we have fully tested the pump. I might have made a mistake at the very beginning. So what I think is happening now is the very bottom floater and the middle floater effectively turn the pump on, and then that pump ends up draining onto the leach field. Then the third floater, as you might have heard up there, turns on the alarm. As the pump drains the tank, they both come down, and then the pump goes off. So with that, we are done. I think we can call the county now and get our inspection taken care of. Boulder County came, they did their inspection, and it was super awesome. It was very anticlimactic because they just show up for like 10 minutes, they say it's good. We just owe them a little bit of paperwork, but we're excited that we are finally getting to those final inspections. So anyway, see you in the next episode.